Hello again, everybody. This is Tom from Every Step Calculus, everystepphysics.com. First of all, I want to say that I've been contacted to say, hey, I put index 8 into the, after they've seen my videos, I put index 8 into the calculator, and nothing happens. Well, you have to go to my site, everystepcalculus.com, and press the buy button and then buy my programs, and then I send them to you via email, and you load them into your calculator here. Over 800 programs are loaded in here for calculus itself, and then you learn how to put index 8 in here into the entry line here, and then you get my main menu. These problems here are trig substitutions, really, just as part of learning. Remember, I just program for tests. I'm not trying to teach you anything because it's such a waste of time, calculus. 30 years I've been in this business, and I haven't found one useful problem. Not one. Finding the area of a parallelepiped is not my idea of a useful problem, or whatever, And integration, a definite integral, which you give a range for it, over a smooth curve using the x-axis or y-axis as the bottom portion, and find the area inside that, and it's amazing that it does that, because I've done that with graph paper and actually did it by hand, and it does come up with an accurate area under that curve, if you got a definite. But these are indefinite integrals because there's no range given. Just quick here too, U-substitution, you take the derivative of what's inside the parentheses here, which in this case is 2x, and try to match it to the outside. If you cannot match 2x in the outside, it's not U-substitution. It's something different, maybe integration by parts, maybe trig substitution, maybe complete the square. Who knows? There's several ways, of course, of doing it, and you're supposed to memorize and know all this stuff at a test to be able to do it. But because this derivative here does not match the outside, in this case it's going to be trig substitution to do the problem. So anyways, we put index 8 into here, press enter. I'm already at U-substitution, but this has 250 or so items in the menu here for whatever calculus asks you to do. You go in here and press that, and there it is. You can put your variables in and do it. You scroll with this cursor here. We scroll to U-substitution and press enter. Secant is in here because you can't put secant in the keypad here. There's nothing in the calculator that allows you to go to secant or cosecant. So it does sine, cosine, and tangent, but it does not secant. So if it says secant in here, you're gonna say yes to the next screen. But since there is no secant here, we're going to say no. Okay, is that clear? We're going to enter the function, the integral. You have to press alpha first. Alpha 1 divided by the square of 9 minus x squared I forgot to put the left parentheses after the division sign, so I'm going to go back here and put it in. Press enter. And I always show you what you've entered so you can change it in case you made a mistake. We don't want to change it, we say it's okay. And we're into the problem. This is going to be using a basic integration rule, which is this right here. The integral of 1 divided by radical a squared minus x squared dx is equal to arc sine of x over a plus c. Just simple as that, okay? Now what is x? Well, x squared, square root of x squared is x, and the square root of 9 is 3. So I tell you that. So a is 3. Right now, we could put on our test paper, oh, the answer is sine of minus 1 x over a, x over 3 plus c, and we'd have the correct answer. But you need to show the work. Here's the theory of it. Here's theta, and of course here's the opposite and adjacent sides of a right triangle. And so sine of theta is opposite over adjacent equals x over 3. X equals, with algebra, 3 times sine of theta. And then theta is equal to the arc sine of x over 3. And we differentiate both sides of this right here to get dx. And dx is equal to 3 times cosine of theta d theta. We have to substitute all of these things to get the answer. We're going to start substituting now. First, here's x squared is equal to 9 times sine squared. We just squared what x equaled, okay? Because we need to put x squared in, and we need to substitute for x squared. So we've got to find all the components of a problem to be able to substitute. And we substitute it here. 9 minus, here's 9 times sine squared of theta for x squared, and here's dx, 3 times cosine of theta d theta, okay? We factor out 9 from the radical. 9 equals 1 minus sine squared of theta. And that allows us to use the Pythagorean identity. 1 minus sine squared of theta is equal to cosine squared of theta. So here we put it in here. We substitute that for this. Still have dx there. And then we square root that system, which is 3 times cosine of theta, right? So this is the denominator, here's the numerator. Turns out to be that they can cancel. So those 3 times cosine of theta cancels, we get d theta, and then, of course, the integral of 1 d theta. Well, when you integrate that, you get theta plus c, right? Now we're going to substitute for theta, which is equal to sine minus 1x over 3 plus c. So here's the answer for that problem. Now we're going to go back and do another problem. I want to do this one here. And so we're going to press alpha 1 divided by, whoops, oh, yeah, we can put the left parentheses in there. Left parentheses, second, x is the radical sign. 9 minus 2, 5 times x squared, left and right parentheses. And did we do it right? Square root of 9 minus 25 times x squared. Yes, that's cool. Okay. I'm going to give you the right triangle again. Special formula, again, is this. Except we got to to get there, we got to get the 25 out of here. So we divide by the radical 25 so that we can isolate the x squared all by itself, like this one, okay? So we do that, we get 9. Oh, I'll show you that we're dividing by the radical 25 here. And when we do that, we get 1/5 outside of the radical, and 9 divided by 25 inside the radical, x squared, okay? Now this kind of just tells you how you got the 1/5. Well, when you divide by, in a problem, any problem, when you divide by something, a certain number like square root of 25, you got to do the opposite to keep the problem exactly the same. So we multiplied by 1 over 5. We bring it out of the radical now. Constants always come out of the radical when you're integrating. And we're left in here. We use a special formula, 1/5 times sine of minus 1x over and a is 3/5 now. It's not just one number. Well, to clean that up, then we need to, when you divide by a fraction, you invert and multiply. So we did that. So we get the answer of this problem is 1/5 times arc sine of 5x divided by 3 plus c. Pretty neat, huh? everystepcalculus.com. Go to my site. You get my help course. You can email me with your tests. I'll show you how to do the tests, quizzes, or whatever practice quizzes you get. You can email me them, and I'll show you exactly how my programs work with those. And I'll help you as much as I can to pass your calculus test, okay? Any problem with loading the programs, you can call me. I'll talk to you in person, whatever you want, okay? So keep that in mind. Hey, have a good one. Good luck in your classes.